Could you give us just a short explanation of what, for non experts, what is quantum field theory?
So it's the notion that the universe is filled with various fields. Each field describes a quantum particle like an electron or a photon, and the actually there's a very interesting, a slightly interesting digression.
Okay.
Maybe I can give. So there's been a lot of debate in physics over the nature of the vacuum. So in Greek times, the early atomists had an idea of a vacuum with particles whizzing around, and there were a lot of objections to this from Aristotelians, and those persisted a long time until the advent of experimental science, the development of vacuum pumps in the 17th century, when it was shown that in fact you could make a vacuum. You could pump the air out of a vessel done by Robert Boyle, for example, only a few hundred meters from where we're talking now. And so the vacuum went back into fashion after having gone out of fashion for a long period. You could make empty space. In the 20th century, it was realized that in fact the vacuum wasn't empty and is in fact a teeming mass of particle, antiparticle creations and annihilations. So there's a lot going on in the vacuum, and what we now understand through quantum field theory is that these processes of particles being created and annihilated all over the place, interacting, scattering with each other, is really at the heart of this alive vacuum. And quantum field theory is really the study of these interactions between particles created out of the vacuum through quantum fields, most memorably perhaps described by a diagrammatic technique developed by Feynman diagrams. So you describe particles scattering off each other through these little cartoons and little sketches.
Which you have here on the picture of them on the front, right? Little. And it wasn't. And Feynman's idea is that you look at every possible pathway, and you sum them all up, and this gives you the probabilities of things happening.
That's right. And when Feynman worked it out, interestingly, an equivalent analysis that he developed had been dreamt up and formulated by Julian Schwinger. But Feynman's way of doing it by little sketches and little diagrams expressed the same physics but in a completely different way, and is the way that is now used. In fact, when we were writing the book, we did experiment with some of these packages that you can make for drawing Feynman diagrams so that they would all look pretty. But in the end we scrapped it and decided to use hand-drawn sketches, because partly it gives the book a little bit more of a kind of lively feel, which we wanted to inject, partly because it was easier to do, but also Feynman diagrams are little cartoons. So it seemed that filling the book with cartoons was the right way of doing it.
And I think part of the idea is that these particles are created and annihilated, so energy and matter are interconverted, as E is mc squared tells you might expect. And so the vacuum isn't empty. The vacuum is full cauldron of activity.
Exactly.